Okay, so these are the notes for 2-6 absolute value inequalities. So what we're going to be doing is we're going to be combining the concepts of solving absolute value equations from Unit 1 and compound inequalities from Unit 2. So first off, if we want to graph the solution on a number line for the absolute value of x is less than or equal to 18, what we want to do is we want to say, well, the absolute value of x can be less than or equal to 18. And then just like we did with absolute value equations, we want to set what the absolute value is equal to the negative value. So x negative 18. But what we also have to do for inequalities, because essentially we're taking the negative x value, so we had to divide both sides by -1. We have to also flip the inequality symbol. Okay, so just like absolute value equations, we have the given inequality, x is less than or equal to 18, but then we also want to find the negative counterpart. So to do that, we want to find what the negative x value is, so we would have to divide both sides by -1. So when that happens, we had to flip the inequality symbol, and we got -18. That's just kind of explaining why we have to flip the inequality symbol, but you always want to flip for your negative inequality. So now let's see what happens when we graph these two inequalities on the same number line. So we want to have the values -18, put 0 in the middle, and +18. Now x is less than or equal to 18, would be closed at 18, shaded to the left. For x is greater than or equal to -18, it would be closed at -18, shaded to the right. So because there is an overlap of the shading, the values are the values in between -18 and +18, including those two endpoints. So what happened here is this is an and compound inequality because we had the two overlapping shaded regions. Okay, now let's try another one. So we always have what's given. Absolute value of x can be greater than or equal to 18. X can also be less than or equal to -18. Again, we always want to flip the inequality symbol when we set that right side equal to the negative number. So now when we go to graph this absolute value inequality, we have x is greater than or equal to 18. So that would be shaded to the right. And also x can be less than or equal to -18, shaded to the left. So this one is shaded in the tails. So this one is similar to an OR inequality. Okay, so one option is you can always write the given inequality without the absolute value symbols, flip the inequality symbol, make the right side negative, graph it on a number line, and see if it's an and or an or. But don't worry, there's some rules that apply here that will make it a little more streamlined for you. Okay, so before we learn those rules, let's now work in reverse. Let's write the inequality from the graph. So remember, absolute value is the distance from 0. So you always want to find the halfway point of these shaded regions. In this case, the halfway point, they're both at 0. So now what we're doing to 0 is there are 4 places between 0 and -4. And because it was the halfway point, there's 4 places between 0 and +4. So now this is graphed like an and inequality. So let's use what we did in the first example, and let's set it to less than or equal to 4, because those are the 2 endpoints, and that's the distance from 0 that these 2 endpoints are. And it's equal to because it is a closed circle. And these will all be so much easier once I'm able to show you those rules. So just kind of like giving a little preview beforehand. So with 2, the 2 endpoints of our compound inequality, what's graphed, is at 3, right? These are both 3 places from 0. So that means that we're looking at the absolute value of x. And in this case, it's an or inequality. So we're going to use greater than, and the 2 values are 3. Okay, so find that middle point. They were both at 0, so we don't need to add or subtract anything inside the absolute value besides just x. And it was less than or equal to because it was graphed as an and inequality. And it was 4 because those are the 2 distances from that middle value. Number 2 was, again, nothing added or subtracted to x inside the absolute value. It was greater than because it was an or inequality, graphed like the second one we did. And it's not equal to because they're both open. And it's 3 because of the distances from 0 that those 2 endpoints are. Okay, now it's time to introduce some rules, and I think it will help bring it all together. So an absolute value inequality can always be rewritten as a compound inequality. And remember the 2 types of compound inequalities we have and compound inequalities, and we have or compound inequalities. So before we get into those rules, we have a couple steps to do beforehand. Our first step to doing any kind of absolute value, either equation or inequality, is always to isolate the absolute value. We then want to make sure the absolute value is on the left side of the inequality. And then C and D are the most helpful steps for solving, writing, in graphing absolute value inequalities. To solve the absolute value of ax plus b just means like anything inside the absolute value. Those are just like generic terms. For less than c, we want to set it up as an and compound inequality. So set up the right side. Ax plus b is less than c, right? That's what's given without the absolute value. And because we know it's going to be an and inequality, we want to follow the direction of the inequality symbol on the right and make that c value negative. This would be the same if we wrote it as ax plus b is less than c and ax plus b is greater than negative c. But we have a lot to do in this section, so it's so much more helpful if you write the and compound inequality as a compact compound inequality, meaning you're writing it all as one line without using the word and. So whenever you have anything that's less than or equal to, we can then conclude that it's going to end up as an and compound inequality. To solve the absolute value of ax plus b, now again, that's just generic terms. That could be just x, that could be 2x plus 1, that could be 3x minus 1. It's just whatever's inside the absolute value. We have the given inequality. Ax plus b is greater than c. And this one is going to be an or. Flip the inequality symbol and make that c value negative. So if the absolute value is greater than something, then it's going to be an or compound inequality. If you know just C and D, you're going to do fine with absolute value inequalities. Less than is an and, greater than is an or. Some tricks I've used, I don't love using tricks because I think sometimes students focus too much on the tricks and less on the overall concept, but I know we have a lot going on, so I will give you my little tricks for knowing which one. I used to say that less than ends up being less work with an and inequality, right? Because we just have to solve that one inequality instead of both of them for an or. And then greater than, if you pronounce it a little differently and you say greater than. I know that's a little silly, but I promise it will help. Okay, so less than is an and. And inequalities have a little less work going on. Greater than, greater than. So in greater than would be an or inequality. So now let's just go back and review the first two examples that we did. Right, this was less than, and when we flipped the inequality symbol and we made the right side negative, it turned into an and inequality because it had that overlapping shaded region. The second one we did was greater than or equal to. So again, greater than, it turned out to be an or because again, it was shaded in the tails and there was no overlap. If we go back and review writing inequalities from the number line, number one was graphed as an and, so we used the less than symbol. And number two was graphed as an or, so we used the greater than symbol. So if you remember nothing else except less than is and greater than is or, you'll do perfectly fine in this particular section of Unit 2. So flip the inequality symbol, make that value negative, and determine if it's an and or an or. So in the event that the graph is not centered at 0, we still want to find the midpoint. In this case, it's at 6. And we still want to find the distance from the two endpoints. So the distance is 2. So what we're saying is, and 6 is 6 values from 0. So what we would do here is we would say, actually, I'm going to do that differently. So what we're doing is we're taking 6. If we add 2 to 6, we get to 8. And if we subtract 2, we get to the 4 value. So what that means is because it's the -2 and the +2, that means that the absolute value is going to be set equal to 2. Now the endpoints are filled in, and it's graphed as an and, so we know it's less than or equal to. And because we had to add 6 to both 2 and -2, x minus 6 goes in the middle of the absolute value. Now on your summatives, or on your formative, you can use your notes, and please do for this. This is very challenging. Okay, so the midpoint value, that's the value that goes inside the absolute value. We're always subtracting it. And the distance from the two endpoints, that's what it's set either less than or greater than 2. We'll do a little practice of this on the Jamboard coming up. Okay, but the bulk of this lesson is to solve and graph absolute value inequalities. So as long as the absolute value is isolated, I always jump right in and I say, okay, this is a less than, so I know it's going to be an and. Okay, so first isolate and then determine what you're setting up. So just a reminder, I'll write those rules here. So if it's less than or equal to C, we have the given information. We flip the inequality symbol and make that C value negative. For greater than, we have the given inequality without the absolute value, or flip the inequality symbol, make that C value negative. Okay, so this one's an and, so set up what we know. We know the x plus 3 is less than 6. And then follow the direction of the inequality symbol, because we know if the smaller value is on the left, the two inequality symbols are both going to be facing the left. And that's the hardest part, just setting it up. From here, we're solving this compound inequality. So remember, we want to isolate x in the middle. So we subtract 3 from the middle, from the right, and from the left. And there's our compound inequality. I'm going to increase by 3 just so I can fit all these values on my number line. It's open at both 3 and -9. And it's an and, so we shade in between. Okay, with 5, before we can do anything, we have to isolate the absolute value. So our first step is to deal with this -3. So we're going to add it to both sides first. And we get the absolute value of 4x minus 5 is greater than or equal to 13. Now we want to determine if it's an and or an or. And because it's greater than, we know it's going to be an or. Greater than, typically, there's a little more work involved because we have to write those two separate inequalities. So that's another helpful thing, is greater than is typically more work. So now we set up the one we have given, 4x minus 5 is greater than or equal to 3. Or 4x minus 5 is less than or equal to -13, sorry. Okay, so flip the inequality symbol and make that right side negative. Now, the one nice part about these or inequalities is the steps to solve are going to be the same. So we would first add 5, and I'm just going to do this all in the same step. Sorry for that background noise. I'm having some tree work done. Hopefully it's not too bad on your end. Okay, so we're multiplying both x values by 4. So our last step is to divide by 4. So yes, it's a little more work because you have those two separate inequalities, but the steps are the same, so hopefully that makes it a little easier. So we get x is greater than or equal to 18/4, which is equal to 9/2, or x is less than or equal to -2. Some of you are not including the word or in your solutions, and that's important because then it shows me that you know it's an or inequality, and so that I can then make sure that your graph matches your solution. So 9/2 is equal to 4.5. So I'm going to go up by 2. So I'm going to start at -4. Number lines are your choice as long as everything fits, doesn't matter. So x is greater than or equal to 9/2, which is 4.5. So just after that 4, greater than, so we shade to the right, or less than or equal to -2, shaded to the left. Okay, so isolate first, then determine is it an and inequality or is it an or inequality. Set up your inequalities and then solve and graph. And the quiz is open note, so by all means, have these rules somewhere accessible to you when you take your formative. Okay, so 6 is already isolated, so we're ready to determine is it an and or an or. This is greater than, so we conclude it's going to end up being an or inequality. So we set up the inequality that's given without the absolute value symbols. Or, right, don't change anything inside, but just flip the inequality symbol and make that right side negative. So both and or, doesn't matter which, either one, we're both flipping the inequality symbols and making that value negative. It just helps to know before you get going if it's going to end up being an and or an or to help streamline your solution a little bit. So the first step for solving, we're going to be subtracting 7. So for the left side, I get 2x is greater than -4. And the other one, I get 2x plus 7 is less than -10. Oh, 2x is lessened. Oh my gosh. We're multiplying both x's by 2, so we're going to divide both sides by 2. Now feel free to do all the left inequality first if you'd like, and then move to the right. I just figured because the steps are the same, it's kind of nice to not think about it twice and just kind of move through both inequalities together. But that's your choice. So we get x is greater than -2 or x is less than -5. So one thing to note also is that the steps for solving these are the same as regular compound inequalities. So if we were to have to divide by a negative, we would have to flip the inequality symbol with these two. That rule doesn't go away. We're just adding kind of a step on the front end of it. -2 and -5 are pretty close together, so we can just use increments of 1. It's nice to have at least one value extra on either end. X is greater than -2, so it'd be open at -2, shaded to the right. X is less than -5 would be open at -5, shaded to the left. Okay, so your other option, and I don't recommend this, but it's your call, is we saw early on that it was going to be an or, and I kind of find that helpful to map your plan moving forward. But your other option is to not think of it as an or and just flip the inequality symbol and make the right side negative. Solve them separately and then graph them on the number line and then determine, oh, that shade in the tails, so it's an or. Because both of them require to flip the inequality symbol and make that C value negative. So you cannot know if it's an and or from the beginning, and then just determine based on the solutions if it ended up being an and or an or. But I prefer to know what's coming. And you get the benefit, if it's an and, you get the benefit of solving that and inequality. And then graphing, you don't have to even think about it. You know if it's an and, it's shaded between. If it's an or, it's shaded in the tails. And then it's nice also if you can kind of catch a mistake. If you know it's an or and it didn't graph like an or, you could then go, it would be a red flag to you, and it would signal you to go back and check to see maybe you didn't flip an inequality symbol, or maybe you didn't do something else along the way. All right, so number 2, we're dividing the entire absolute value by 2. So we're going to start by multiplying both sides by 2. So we get the absolute value of 3x minus 4 is less than or equal to 8. It's a less than, so we know it's an and. So then we set it up. So it's helpful for spacing to kind of move a little bit to the right. Set up your right side. We're flipping the inequality symbol, so we're just following the direction of the right side inequality and making that left value negative. So it's still flip and making it negative. We're just writing it all in one, which helps us get to the solution a little faster. Our goal is to isolate x in the middle there, so we're going to add 4 to the middle, the right, and the left. I do my best to give you as many integer solutions as possible, or integer endpoints of the inequality as possible, but there's only so many out there, so it's very common to have at least one fraction in these types of problems. So don't be alarmed by fractions. Hopefully they're just not too crazy of a fraction for you. So now we're multiplying x by 3, so we're going to divide all sides by 3. So remember, we read these from the inside out. So x is less than or equal to 4 and greater than or equal to negative 4/3. And negative 4/3 is equal to negative 1 1/3. I'm going to go up by 2's on my number line and then just approximate where negative 1 1/3 would be on that number line. Actually, let's go. I'm gonna go by 1. But you do what you want. As long as you write the solution, your number line can just be an approximate estimation of where that fraction value is, as long as you have the solution. So it's closed on both ends. And it's an and, so we shade in between. If you didn't determine it was an and up front and you just flipped and made the value negative, you would have to graph both. So you would say like x is less than or equal to 4. So you would shade to the left. X is greater than or equal to negative 1 and 1/3. So you'd shade to the right. And because of the overlap, you could then determine it's an and. So you'd want to make sure you write and in your solution or write it as a compact compound inequality. These are going to take some practice, and that's majorly what we're doing for the last 20 minutes of class, and then it's all of your homework, and then we're also reviewing tomorrow. So as long as you have those steps out in front of you somewhere, I think you'll do fine. And our word problem. Okay, so whenever it says plus or minus, that's what we know it's going to be set equal to. And inside the absolute value is the actual value minus the average, the same as absolute value equations. And we just have to determine if it's is it an and, like is it between those values or is it an or? So in this case, that keyword range, that means it's going to be between those two numbers. So let's think about this in context. So your body temperature is in the normal range if it's 98.6 plus or minus 1. That means it's normal between 97.6 through 99.6. So range means and. Now 97.6 and 99.6, those values are included in the range. So the inequality symbol is going to be less than or equal to. Because those values are included, we have to set it equal to. So the actual value, that's just what we deem as x, minus 98.6. This is less than or equal to 1. Okay, whenever we model a situation with absolute value, it's always going to be minus. And whatever the plus or minus is what it's set equal to. And then your job is to determine what the inequality symbol is. Is it this or that? In that case, it'd be greater than. Or is it between those two values? And in that case, it's less than or equal to. Okay, so that's it for the notes for 2-6 on absolute value inequalities. I know those were a lot of notes, but we had to kind of use this lesson to review compound inequalities, bring in a new concept of absolute value inequalities. And hopefully I didn't go too fast, but if I did, this video will be posted to Canvas.